pick up the roadkill?
Well, see, roadkill would be easier because I don't think I could catch a squirrel. Like, I think it would like be one of those like videos that would go viral if it were a video of me trying to catch a squirrel.
You diving after it and such?
I mean, I can't imagine I get even close. There's a really cool video of this guy who's like set up like this weird obstacle course in his backyard to like to get to the feeder. And you're watching these squirrels get smarter, figuring out how to break their his get to the stuff.
He figured out that they just jump straight past the certain ones.
Yeah, they're pretty bright. I see another guy who he's got a I don't know, I think it's an octopus in a aquarium. And when he feeds it with the food like inside different jars and stuff. And the octopus has to get it open and like untwist the jar and get it. It's pretty fascinating how they solve problems.
Yeah, and like they solve it typically different than the human would.
Well, I would hope so.
They're not.
Because that would also be a fun experiment to have a video, see if we can get the Lippmann viral video of me trying to, get to my little shellfish inside of a, sealed jar in the bottom of the ocean.
Just has to Vader.
Well, Vader, but you got to get it on the right side because Vader's blind. Vader's blind on one side. Vader's our pet Oscar. All right, so let's jump in. Blah blah blah. Do I got everybody? Okay. All right, so we're going to talk about a couple of new things today. A new thing, and then we're going to keep taking our Pokemon in this direction. So up to this point, I think we have us processing the JSON, kind of proving we can manipulate it. Last time we talked about this idea of it being kind of a map that can contain maps and array lists. And we also saw that you can also hold values that are longs. We saw that last time. Did we see string as the other one? And then array list, whatever it was. We saw some of the different types for this. Let's see. Then we started completing the homework saying, hey, and here's your menu. Do you want by this? Do you want by this other thing? I'm not going to finish it this way because we're going to move it into we're going to start talking about something called design patterns, and then we'll finish it using the design pattern. Okay, so let's go into the notes. 3D printer's done. All right, so just as a quick recap in case you weren't paying attention to this slide, can anybody tell me what we would use this program called Postman for? And it is Postman, not Postmon. Although Pokemon has an M-O-N, right? Pokemon? Yeah, so it's not spelled different. So who can tell me what the program Postman is used for? Keep in mind, it's near slides about HTTP. Proximity. Oh, God. Go ahead.
Did you say something to I can't remember what you said.
All right, that is more right than I expect. No, it's not right. You got like the first 4%. Hey, that's better than usual for you. You take it. So we've looked at how we can test our API endpoint for our Pokemon we've been using. We can actually test it with just the URL in our browser. Why are we able to do that? By just pasting that endpoint into the URL of our browser and pressing enter and seeing the data. Why does that work for that? But it doesn't work for other. It won't work for all endpoints from all APIs. Why does it only work for some of our endpoints to put it up in the URL? This is actually important. In fact, I might even say the knowledge of this is probably the most important of the kind of the lesson we've been looking at, because this gives you the this weaponizes you for to go out into the real world and being able to leverage APIs and use them for all sorts of things. Now you don't have to do it with Postman. Postman is just kind of a program that lets you do it. But the reason why you can paste the endpoint into your browser for our Pokemon thing is because that particular one has to do with getting information. And because it was implemented, you know, the way it probably should have been, when we get information, we do it with a GET request. This guy right here. Whenever you put something in your URL, that is a GET request, whatever you're going to. So when you're speaking HTTP to Google's web server and you say, give me www.google.com, that is a HTTP GET request for that. And it responds with the HTML, JavaScript, and CSS for that page. So because this is also a GET, our Pokemon thing, we are able to paste it into the URL and see it function. But if we were using a different endpoint that was either a post or a put or a delete, we mentioned that, well, we could technically build our own little tester. We can create a web form on a web page, change the method for what it does. Say the method is always either get, post, put, delete. Usually if you're a web developer, it's either get or post. In fact, it probably always is get or post. You could probably meet a web designer who's been doing it for a decade and they may not have ever heard of put or delete, or at least never called it. It's just a reality of the tools. But when we go to APIs, we take advantage of all of them because that's the reason why we chose HTTP as our backbone of all of our modern APIs, is because, hey, these things are already built. We already have the language. We don't need to invent a new language to speak to our API thing, because really our APIs are effectively served by web servers. Just when we say the word web server, what connotation? If I say you're going to be communicating with a web server, what does that mean to you? What does that tell you? So first of all, when I say web server, the word server can mean two different things, right? So it can mean a physical tower, physical thing, but probably when we're talking about it from a computer science programming perspective, we're not talking about the hardware. We're talking about something that serves information, serves data. That's the server. It could exist in a computer that's in the other room, probably exists in the cloud somewhere. If you're a web developer, might even exist here in your computer while you're developing it. How many of you, so let's keep going down our rabbit hole here. Oh, by the way, I will deny this if anybody asks me about it. I do want to compliment this class, except for Carnival.
Yeah.
A majority of this class, I could tell, worked really hard on that last assignment. You grappled with the API, things like that. Most students don't do that. I mean, usually I have one or two, but 80% of this class, I could tell through legit hours at that. So I appreciate that. I'm not just wasting my time. I'm mostly wasting my time up here. But I'm not only wasting my time up here. So you did legitimately do a good job. All right. So now, what was I about to talk about? No, that's a good one. No, that's star for the day. You'll lose it, but you know, you're working on positive currency right now. How many of you have heard of the mean or MERN stack? Have you heard of these before? Which one have you heard of? Both? You're playing video games? You playing video games?
No.
He alternates between video games and sleeping.
Yep.
Class. All right. So who's heard of the mean stack or the MERN stack? You heard of MERN stack? Do you know what is the MERN stack?
React there.
Oh.
Node.js.
Okay.
MongoDB.
Oh.
Express. Yeah, that's.
Oh, okay. All right. So let's unpack that. You said Express. What is Express? Let's keep diving down. But well, first of all, he got it right, so I'll say it for the recording and stuff. So So the mean stack and the MERN stack, he said, the M is for MongoDB, E is for Express, R is for React. You may have heard it as React Native. And N is for Node.js. For mean stack, it's MongoDB, Express. Do you know what the A is? It's the competitor to React. Do you know who made React? Facebook made React, now Meta. They made it before they were Meta. So it was their internal tool for creating their web-based user interfaces. So Angular was, well, A is Angular. That's Google's internal one. They both basically do they have the same approach. And it does feel like React has kind of become the winner, maybe, mostly the winner. I'm sure internally Google still uses Angular, but they're very similar things. So MongoDB, what is that? Database, a thing to store our data. And could anybody know what the difference is between MongoDB and like a database like MySQL? Or PostgreSQL, or Oracle, or Microsoft SQL Server? You're not going to learn this at database. I think we all know that. Look, if you're not hearing about it out of this head, you're not going to learn it. All right, so those other databases that are still quite popular are what are called relational databases. So MySQL, these are ones that use SQL as the query language to talk to them, asking it for, take these couple of tables, merge them together, give me these pieces of information out of it, all this stuff. Relational databases are still probably the most popular that are out there. The issue with them is their main goal, because of when they came out, and this goes back to us talking about memory used to be expensive. Storage is a form of memory. It was expensive. So if you needed to store data, you needed to make it a priority that you were not going to store the same data more than one time. Let's not waste our space. You had to be real efficient with your storage space. So that's where relational databases came in, like MySQL, PostgreSQL Server, Oracle, basically all of them except MongoDB. Let's go with that you've heard of. So these store things in separate tables, and then when you need information to be linked together, you join tables together on a primary key that they share, like a user ID or something like that, some small piece of data that joins those tables. Whereas MongoDB stores things as objects, actually stores them as JSON. So it's JSON that actually gets stored in there as an entire object. You still query it using a very SQL-like language, but several things no longer make sense, like joining tables, things like that. They aren't a thing anymore, but it still feels like SQL if you're used to that. Go ahead. Well, today, MongoDB. And the reason, can you make a guess as to why MongoDB would be more popular? Keep in mind, I just said that relational databases were a necessity back when memory was expensive. So now memory's not so expensive. And he mentioned large scale data. So really what we're talking about is, let's say, for instance, you take some giant application. Let's go with, you're logging into Amazon. All right, you're logging into Amazon. How many people are logging into Amazon at this last 5 seconds? Let's round up and say a lot. All right, so, and those people are all over the world, right? So what you would start off with is probably wanting to have distributed databases closer to their regional place. That means you're actually duplicating the data on purpose into all these different locations, but we have the storage for it. So we can actually scale with more users with the same data because we actually just sync the data above. It's kind of like a cloud storage type thing. And then we can spread our data out by serving object, because we'll just store the same object 20 times. Who cares? But that's kind of, it leans into that as opposed to having to sync a whole bunch of individual tables that only hold parts of your data across the board. So it lends itself to these web services, cloud computing things that have what's called elastic scaling. So you buy a certain, you buy a server in the cloud and you pay for a certain level of service. And then what it'll do is it'll stretch as demand increases. It'll stretch to a higher level and you can put your budget on it. So it won't charge you too much, but it will, instead of your site going down, it will stretch temporarily as you're getting a whole bunch of traffic with more resources, more memory. It'll charge you for those as a emergency situation, but your site will stay up. That's the scalable stuff. So these guys are, when I say full stack developer, if you look at jobs, internships, whatever, you probably see something that says full stack developer on it, right? What can you tell me? What do you think a full stack developer is?
They develop a full stack.
Okay, what's the stack? Something like this. All right. So these are considered stacks of development tools. Now, why is it that we consider mean or MERN to be a stack? I mean, what's good about this? Go ahead. Yeah, so that's the answer to a different question. Yeah. So I mean, the reason that we would say full stack developer is we are hiring a person who has background in the data storage part of it, the serving, the back end side of things, the front end interface development, as well as the other side of the server. So when we look at this, Node.js is an overarching technology. It's like a competitor to Python. So Node.js uses JavaScript as the programming language, and it kind of became popular for web developers who were not full stack developers. And so they were used to only doing the front end stuff. So they were used to working with effectively just Angular or React. And they were always sending their information to some magical backend somewhere. And fine, sometimes that backend is doing complicated things that probably a web developer may not have the background for that. They probably went to school for design or something like that. That's why they're a front end developer. But these aren't stupid people. So there are some aspects of things that are happening on the back end that are certainly in their wheelhouse. Validating forms, handling authentication. Like, okay, give me a username and password. I'll check if it's right. You're not doing major heavy lifting logic on that side. So introducing a backend like Node.js, which uses the same programming language as the front end when they're writing HTML, JavaScript, and CSS, when they're doing the front end of a web page, you're using the same programming language. And even though I teach from the perspective that the language doesn't matter, if you are someone who's not a programming skill set, you're a designer skill set, having something you're comfortable with is an important aspect. So Node.js being your back-end server, that is the thing serving your entire application. That guy is the code you interact with that with is JavaScript. Now, Express, anybody tell me what Express was? So Express is a package that you install. You don't even know what Express is?
I was about to make a guess.
Okay, make your guess.
Is it just communicate between the front and back end? Kind of.
Hold on, I'm trying not to throw up. Okay. It's not a horrible, it's not technically wrong. It just doesn't say anything. All right. Express is a web server. So you use Node.js, you install a module called Express, and that module Express speaks HTTP. So
That's what I was trying to get.
That's what you're getting at? Yeah, I just didn't let you finish.
Yeah. I just said it really short, really dense that, but that's what
All right, so what was I talking about? I blacked out for about 5 minutes. All right. Did you see that for the movie Old School? You never saw Old School? Oh my God, you saw Old School. Will Ferrell. Yeah, it's hilarious. You have to watch Old School. It's had to be 20. They need to make, it's one of those movies they have to make a remake of. So it's these old guys, they've been friends since college, but now they're working professionals and stuff like that. Well, they decide to go back to school, they create their own fraternity. They let all the people who don't get into the other fraternities in. Yeah, you got the old guy Blue. Uh, yeah, yeah. And the guy becomes like the Godfather. He like, oh, that's a great. They make their house wall to wall sand. Oh, that's the way to do it. So good. Man, how did I even get to old school from that? What was I talking about?
Nothing,
Oh, yeah, how did you get
nothing.
This happens to me all the time.
Express server.
Yeah,
Express server, HTTP.
Dax is what does Express do? He said package, he said he's basically wrong but right, and then you talked about how Express is a server.
Oh, yeah, I'm not there yet. No, we'll see. It might pop back up. You still have to watch the movie, so we'll call that the actual point of that statement. So Node.js, we install a module called Express, and that module then we can load in our program and tell it to listen on. We tell it the port. If we want it to be like a real web server, it would probably be port 80. But usually your little Express server, you might be running on the same physical computer as a web server is already running on. So you don't want to take its phone number. So port 80, the port on your computer that it's listening on, which is a software thing, we have 65,536 unique ports on most modern operating systems. The first 1,024 of which are reserved for the root user, the operating system itself. So 1,024 on, because it's 0 to 1,023 is your 1,024 first ports that you're not allowed to use. You can't choose port 75 for your program because that's already, port 80, you can't choose that because that's already reserved for HTTP by the server itself. So you would pick port like port 8080 is common. Or if you do a lot of applications, you just pick, I like do port 5000. I just keep counting up by one for my applications that I run on one of my servers. But so you configure Express as to what port you want it to listen on. So he starts off and he just listens for that phone to ring. But the language he speaks is HTTP. So that's his job, is to be the HTTP listener, which is what you need if you're going to be writing the back end for your own API server. Because whoever's yelling at your API to get information is speaking HTTP. So Express, you build out endpoints in Express that do different things, and then that guy listens for that endpoint on whatever port it was, speaking HTTP, and then passes that information on to the inside for you to write your normal programming code to accomplish whatever task you're asking for. The Pokemon stuff, fine, I'm going to go read from all my files where this stuff lives. I'll put it all together in JSON for you, then out the door. That's what that guy does. So when we talk about full stack developer, what we're really, blackout. That's where it came from. I said I blacked out. Near the end of that movie, there's this big competition where these guys are going to get kicked out of school. And Will Ferrell gets up. So, the school wants them out. So they hire all these like famous people. Like they hire this famous debater guy who you've heard of, Carville? Because James Carville. And he was a lot younger back then. He's an old guy now, but he was like known to be like a really great debate person back then. Probably still is. So they brought him on stage, basically like, they were stacking the deck so the school would win. Will Ferrell, who's like a complete idiot in the movie, he steps up to the podium to compete against this guy. They ask him some question that, he wouldn't even have understood what the question was. It was so like, geopolitical, complicated, whatever. And then he just rattles off like this perfect response and wins. And he's like, what happened? I blacked out. That's where it came from. Okay. Man, it must be frustrating to be a student in my class, I tell you. It should be entertaining, but frustrating, I can imagine.
Like two class.
I know, it's terrible. My wife yells about this too. All right. So anyways, full stack developer, when you see a job for full stack developer, what they're really saying is we expect you to handle all aspects of the application. The user the front end, the back end, the logic in the middle, the data storage, the whole rigmarole. They want you to have that knowledge of all those things. Now, usually as a full stack developer, when you choose the right tools for the job, you want to pick technologies that kind of play well together. It's not that you can't pick something else other than Express that could technically do the job or even write your own HTTP server. I mean, it's got 4 endpoints. just do it. These are technologies that are known to be very compatible with each other. They already have kind of some built-in hooks that talk directly to each other by default, things like that. They play well together, so these are considered kind of popular stacks. There's a stack called the LAMP stack, where the P is PHP, the M is MongoDB, the A is Angular, and oh man, what is the L? So we got Angular, it's the front end.
Lua.
It's not Lua, but it's got to be the web server. I don't know, I'll have to think about it. But that's another popular stack. All right. So we were talking about Postman. So Postman is this tool that allows you as a developer to test endpoints for your APIs without you having to build a bunch of extra stuff. It runs on a website. You could also download an application to your computer. It lets you put in, here's the website that I'm going to, the URL. But then if you're using posts, puts, or deletes, it lets you go ahead and add the extra variables you want to have, even like API keys. It lets you add the headers, it lets you add the name value pairs, as if you read it in from a web form, but it lets you just plug it all in and then test the endpoint to make sure that what you're trying to do programmatically actually works right now the way you think it's supposed to work. That way, when you then take it over to your program, you at least know that part works. Now it's on you to deal with what that guy gave you. Make some sense? So Postman is a tool for handling that. All right. So now that we know all this stuff about HTTP and things like that, let's talk about something called design patterns. Anybody heard of design patterns as it relates to computer science before? I'll give you a couple of patterns. So we have MVC is one pattern. We have Singleton is another design pattern. There is a design pattern called factory, which actually has a lot to do with Singleton. So I'll merge them together. We haven't heard any of these. Okay. Well, we're going to focus on Singleton today. But before we do that, so a design pattern, what's the definition of a design pattern? This is a proposed good, good solution to a common problem. Now, good and common are in the eye of the beholder, right? So good and common are in the eye of the beholder. The example I like to use is making a peanut butter and jelly. So, everybody knows how to make a peanut butter and jelly, or at least is aware of the creation of peanut butter and jelly. Now, you might have different techniques for making peanut butter and jelly, because the peanut butter can be a problem and the jelly can be a problem. They have different viscosities. Some are sticky. They won't come off the spoon, all sorts of stuff like that, right? So we have different techniques for making them. How do you spread it without, breaking the bread, all this stuff. So we have different approaches to making peanut butter and jelly. So let's assume that you have what you think is a good solution to making a peanut butter and jelly. Okay, so what I do is I take just the one. I usually toast it, but even if I don't, I just take the bread. I put a big dollop of peanut butter on there, and then the spoon still has a little bit on, so I eat that, and then throw it to the side, and then I dump jelly on top of that. I might use the same spoon since it's my jelly, but well, in this case, just follow me. This is my design pattern. Okay, so I got one piece of bread, pile of peanut butter, jelly on top. And I take the other bread and I just smush it. Don't smash the bread too much, but you want to get them, That you get it all spread out that way. Bread is in good shape. That's the perfect way of making a peanut butter and jelly, in my opinion. That's an example of a design pattern. Now, you can decide whether you like my approach or not. So you can imagine, so design patterns is something for, maybe it's kind of lost a little favor now, but for years, design patterns were academics' dream. Because in academia, you usually have to do something called publish or perish. So we're supposed to do research, publish papers, things like that. Well, design patterns typically have a crazy name. They're typically solving some problem. Anything under the sun is fine. And then it's just like, hey, here's a proposed solution to this. And at the end of your research paper, you can say, yeah, this didn't work. That's acceptable research. You try something, and then you tell the world of researchers that, hey, you don't have to try this yourself. It doesn't work. So design patterns were an easy way of getting research papers. So a proposed good solution to a common problem where good is in the eye of the beholder, plus what's a common problem? A common problem to one person is a completely different thing than a common problem to like Lockheed Martin that's making missile guidance systems, right? You know, their common problems are going to be very uncommon for a normal person. Go ahead.
I was gonna ask that, like, what I'm telling you, like HTML and CSS, there are like similar ways to get to the same result. Like most people would probably do what I do in 30 less minutes. So is that kind of applicable to what I'm thinking of?
Well, I mean, I think it's somewhat related. So, you know, you're saying that when you're working on a problem, there's different ways of getting to the same solution. And depending on the nature of the problem, that kind of dictates like how seriously you take the optimization of your solution. You know, if it's just like a, hey, this just needs to happen, you might just slap it together in a way that works, move on with life, save yourself a half hour. You know, if it's something that's in production, it needs to be fast, or at least it needs to be used by other people. You might want to package it a little bit nicer so that people can interface with it easier, where, you know, you're kind of playing like the, the puppeteer, where you know where all the variables are and the strings, so you're manipulating it, but, you know, you have to know that your variable I here is shockingly important to the whole algorithm, stuff like that. But yeah, it would be that type of thing. But even within that, you could still choose to use a design pattern as your approach, but just kind of slap it together, you know, for you if you know that you're the only one using the application. Well, I want to talk about Singleton first. So Singleton is a design pattern, and this guy says it's a good idea to keep things that need to be accessed by many other things. Well, let's see, by many, let's say just many other things in a single place. So if you're in an apartment and you have 3 roommates, and let's say you share a car, you know, poor college students, didn't have a ton of money, went in together, bought a used car, it kind of starts, but you share it. You got one set of keys, or each, you know, whatever, let's just say you have one set of keys. So you keep those keys in a central drawer, a place that everybody has access to them. So if I need to use the car and I go to that drawer and the keys aren't there, I know that that resource is not available. The keys are there, I can take it because the resource is available. But we've made it easy for all of us to access the resource we need to have access to by putting it in a kind of a common place, a public place that we all have access to, as opposed to somebody keeping it in their own pocket, everybody having to text around to see who has the keys, blah, 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 that kind of stuff. So Singleton says that. Now, what's interesting about this is this is in conflict with an old saying in coding: never use global variables. So generally speaking, programming has his history of programming, and this kind of became popular way before many evolutions of programming that we have now. If you had one variable that you what people would do, beginning programmers, to make their programs work because they didn't want to have to learn scoping rules. So all of you in here have had to learn scoping rules, and some of you still struggle with it. Like, hey, why don't I have access to this variable here in this inside of this function? I defined it up there, but you don't have access to it here because it's not in the scope. It's in the scope of this function where you defined it inside of another function, maybe main or something like that. So you've had to learn scoping rules. Well, in the early days, a lazy programmer, instead of learning scoping, may have just said, oh, I'll just put all my variables at the very top. Why? Well, because the errors go away. Because now that variable that it just told you you don't have access to, you now do. Because you moved it from its old scope into a global scope that now everybody has access to. Which is great because that's exactly what you wanted, is the errors to go away. Now you've locked yourself in, you can't use the same variable name multiple times because now it's taken because you're using the top level scope that everybody has access to. But the old saying would have been never do that. Maybe never say never. It's sometimes it is the right tool for the job rather than passing the same stupid variable to 20 different functions. Just put it globally so they can all access it. Just do it. But just do it for that one variable. Do it targetedly. Do it for a reason. Not because, oh, I wanted the errors to go away and I just tried everything until it stopped. And then what you have is a working program and you have no idea which knob you turned to get it there. You don't know if it was the last thing you changed or that was the culmination of the first 11 things you changed. You don't know how you got there, so you actually don't know how your program is actually functioning. It just does, so you turn it in and say, ha, it's good. But you actually missed the most important learning part of it. Fix it the right way. Don't just fix it till it works. Because I don't care if it works. I care that you learn something while doing it. Most of your previous programs for the previous assignment didn't work or didn't work completely. But I can see how much you struggled with it to try to get it to work. That's way more important than taking a shortcut or something like that. Okay, so Singleton, usually we're thinking about this though at kind of a level up where we're thinking about this in terms of an object. So rather than having like a single integer that's shared among my entire program, we're really talking about elevating an instance of an object up to a point, or even a class that everybody has access to. And this is actually one of the best uses of static methods, is if you want to have a single thing up there and I'm just saying, hey, API helper, help. And you're calling one of its functions to do something. All of your objects in your entire program, everything in the same directory, will have access to that top level object, so you don't have to pass it around all over the place. That's a decent use for it. All right. So what we're going to do is we're going to see an example of a singleton. Then we're going to move our Pokemon up into a singleton so that it effectively acts as like that's kind of where I said that factory and singleton kind of mixed together. So what I want to do is I want to have this tool that is an object that floats above my program. We want to think about it like that. It's just for us, it's just going to be a plain object. We just happen to have it in such a way that it is available to every single part of my entire application if needed. And we're going to think of this as our little Pokemon factory. We have our Pokemon Singleton up there, which is our one source of truth for all things Pokemon. And no matter where we are in our program, we always have access to our Pokemon Singleton, and we can ask him give him a name of a Pokemon, and he gives us all the rest of the information, maybe as a map or something like that, or he gives us an instance of a Pokemon object that was built using the map of the fields for that object, and now all of a sudden we have a plain Jane object, right? Now, we saw that when we run our program, I think it's currently still in a running state, is it not? I don't remember when I stopped class, if I was in the middle of doing something or... Equals ignored case. Where is that? Oh, I was writing all this. So here, I'm gonna get rid of this stuff anyways. So I'll just dump that for right now. Ooh, don't lose my code. All right, there we go. So it's asking me some information. I don't remember what I log in for here. I think it's GitHub. All right. So we saw it run, but we saw it takes several seconds to run, which doesn't, it's kind of, that feels weird to us because our programs usually run instantly, right? Well, it's because it's having to go over the internet, it's having to download all this text, then it's having to process all that text through our JSON parser and things like that. Now, if I run this program again right now, do you think I'm getting different information from the Pokemon API? Have new Pokemon came out in the last 30 seconds? Probably not, right? We pretty much know when there might be a new release or something like that. Maybe an API might say that our data sets have been updated or whatever. So really in our program, we might decide to say, hey, I actually only need to hit that one time ever. Or when I launch my program, I wanted to ask me, do you want to get new information or do you want to use our cached information, for example? That way it doesn't have to take the 10 seconds to process everything because it already has it. And we're just going to store that information somewhere so it maybe runs a little quicker. We could make those decisions. All right. So, but I'm going to start off with a simple singleton. And then we're going to see our example of how it works. Now, something I'll say is the way I write singletons, which I'm going to argue is the right way to write singletons, is, well, I'm going to argue yeah, it's the right way to write singletons. If you use an IDE like Eclipse or for Java, something like that, it has something built into it, like, create singleton. So it'll create a class for you that behaves as a singleton. And it does a bunch of weird stuff that's unnecessary. It lets you create an instance of it and then talk to it. It's not completely weird, but it's unnecessary. Go ahead. Integrated development environment. So super text editor. It's a text editor for writing code. So it doesn't capitalize stuff, or it has, when you put a period, it gives you the command completion stuff, that kind of stuff.
LEJ.
IntelliJ is one of them. IntelliJ came from what was the well, NetBeans is much older. NetBeans was the original Java IDE. That was before Eclipse, before any of the other ones. What do you think? What is NetBeans?
Isn't that like,
That's the one made by Oracle, who originally was made by Sun Microsystems. And the beans part of it is because of Java. Get it? Java beans, coffee beans, Java, cup of Java, coffee. But yeah, that's from the very early days. So the original Java IDE was NetBeans. Okay, so let's go ahead and write a singleton. So I'm going to create a new file. Oh, am I not logged in? Oh, I'm logged in. Help! Oh, it's because my program's still running. See, this is why I need adult supervision. All right, now I tend to name, just like I name my main file, I call it driver because that's the thing that drives my program. I like to name, if I have a program that only has a single singleton in it, like I kind of have this one global place that I keep stuff that's needed throughout my application, but very rarely do I have to have multiple singletons in an application unless this thing's just getting huge. Like we're talking like operating system level application. So I like to name, for no good reason, my singletons core. All right, so I'll name this guy core.java. And we know that core, if the file's name's core.java, it has to live inside of a class called core. So we'll say class core. All right, class core, and we'll do that with it. All right, now what will happen in other so if you use like Eclipse or NetBeans to create your Singleton, it's going to do something where there will be a constructor, and then it'll have a function where you ask that function to give you an instance of that class, because an instance is born in the machine. So when this guy is first created, we create an instance. The instance lives inside of the class. You ask the class for that instance, and then you use that instance to call all the static methods. That seems stupid. You don't need an instance. Just make everything static. And if you need to call function A, say core dot function A. Don't say core dot get instance dot function A. Dumb. Well, I mean, realistically, they probably make the argument of some sort of performance thing behind the hood that may or may not even be true anymore. But who cares? This is not, I mean, we're not doing super heavy lifting here. You know, most of your singletons are not solving all the world's problems. So it's just a place to store some data. Even if it's a little bit more inefficient, if it makes your life easier, just do it. Your processes are fast, right? Just make it work. Yeah. So what I'm going to do here is I'm going to create a couple of well, let's create a method. So I'm going to create a static method. So remember, when something is static, that means it's owned by the class. Therefore, we get to it by using the class name, not an instance of the class name. So let's do something like static int h, something like that. You would only do public if you were really trying to, you want it to be accessible outside of this package. Public means accessible everywhere. Private means only accessible inside of this class. Protected means class and children of this class. If you don't put anything, it's package level, which means if you have something that lives in the same folder as this guy, he has access. Probably what we want here. So we're really not taking a shortcut. We're choosing to let the default be what we actually want. But if you made it public, nobody's getting shot over it. It's fine. All right, so here, I'll actually give it a default value. All right, so I'll give you my behavioral age here. No, nobody got that. They can't even recode. All right, so let me, just for the time being, all right. All right. So effectively right now, main is empty. So if I run this, my program will run, but it won't do anything. All right. So there's my program. So now what I want to do is I want to access that variable age. Now, when we looked at core, we saw age is an integer, but more importantly, it's a static integer. Okay, now static means that this guy owns it. So our mechanism to get to this variable is through the class name itself, not an instance of the class. So we would do something like system.out.println core.age. You use the class name dot the static member of the class. And this will print out 5. All right, that makes sense? So we can throw whatever we want up there. Super convenient, right? And so I'm going to take this exact same line. Let's see, what's the easiest way to create something here? Oh, I think is the JSON parser constructor. No, that takes something here. I'm going to write another class. So we're going to call this my dumb class .java. This will be class. Oh, I don't really want to spell that much, but whatever. My dumb class. And then we're going to say in the constructor, so we'll say public. I didn't need public there, but I don't want to untype it. So we'll have a no argument constructor. And inside here, we'll say system.out.println core.h. So a whole different class. And when I create an instance of this guy, his constructor himself is going to just print out the value of that variable that's in our singleton. All right. So now inside a driver, I will go and I'll create an instance. I'll say my dumb class MDC equals new my dumb class. And as part of that constructor, it is printing out that same variable. So we're proving that that core, that singleton we have is accessible all around our application. Okay, I just invented this brand new class and I'm referencing core in there without having to pass anything. I mean, my dumb class, where that guy is, this has nothing in it except an access, a call to that singleton. All right, yet he has access to it because we put that stuff inside of our single variable. So we'll get 5 twice. Hey, you missed it. You missed it. There's like 5 lines in there. You should have already had it memorized. There's the whole class. But we still have the 2 5s. So you see how easy it is for you to let other parts of your program get access to these global variables. Super easy, right? That's almost the problem. Because it is so easy, and because some of you might still be shaky on your scope rules, where you're like, okay, well, I want my program to work, as opposed to I need to learn about scoping. Because scoping is not hard once you understand it. You just have to screw up enough times that you know, it's the same thing as we were talking about the electrocution thing at the beginning of class. See, what's fun about this is before the recording, so now people are thinking like, is he electrocuting his students? The answer is yes.
Yes.
The answer is yes. Okay, it's not that I am, it's that I want to. So just know it will be premeditated.
Wow.
Hey, wait. With my back though, I don't think I could handle those cots.
What?
The prison cots. The beds.
No.
You'd be a stable receiver though.
That's we're on recording, but you're probably right. There's a whole backstory to that, actually. Go ahead. Sorry. This guy. He has really like serious migraines. And so he has to take medication at certain times and he's trouble getting up. So now he has a new alarm clock that will like shock him awake. And he has to get up and scan it to get it to stop. I mean, I doubt very much it's like hitting him with heavy amps. He's sitting there. Oh, here's a crazy question. If you went to the mall and there was a thing that was $10 and it was a tase cage where you could experience being tased, would you do it for $10? Just to know, really. I mean, we've seen the videos. They all survive.
I don't think I'd be willing to do that. I'd do it, but not for $5.
You wouldn't you wouldn't do it for $10, you'd do it for $5. Where's it's a race to the bottom, just like the App Store. How cheap do you have to get? How cheap does it have to get before you'll willingly get tased? I would do it for 10.
I'll do it for free.
No.
I would actually probably do it for 100.
You would do it for $100.
Well, I mean, I wouldn't like go back on a daily basis, but I think it would. I mean, I've never been tased. You know, I haven't been arrested or anything yet. Let's say. I mean, we have a couple of premeditated things that are cooking. But I don't imagine that any time in my life I'm going to likely be tased.
But and then you fire the people that taste it.
Well, I think that would be interesting to just understand like what that does. To have a better understanding, like, okay, is this a appropriate way of controlling someone, or is this, just to have a better feel for it? Because right now we're just visually seeing it. Pun intended. That's actually the type thing they would have. Like all these new cruise ships keep coming out with like new crazy things. Like Carnival has roller coasters on one of their cruise ships. Yeah, the Mardi Gras has a roller coaster on top of it. Just replace all that. And most of them have ropes courses or some of them have zip lines. Some of them have these like giant robotic arms that will like pull you out over the ocean. All sorts of crazy stuff. So they all keep coming out with new things. They already all have water parks. Yeah, I mean, seriously, most of the cruise lines that cater to younger families have huge water parks on them. Yeah. So the whole families just stay up there all day.
How big are these like ships? Like,
1,100 feet long, 250 feet wide, 20 stories tall.
So it'd take you like an hour maybe to like walk around it.
Well, to walk every floor.
No. Just like if you were to walk just
One end to the other end is probably a 8-minute walk or something like that. From walking through the lobby or the promenade. These are huge things. They're huge things. Yeah, but you go into the normal, poor people hot tubs. Yeah. Oh yeah, I get my spa pass. I have the. You see a guy across the thing wearing a straw hat, drinking weed, or smoking weed, you've arrived on a Carnival ship. All right. Okay. So anyways, I would pay to get tased. I think that would be an interesting thing. I would do it once. I believe I would do it once. It's possible I would enjoy it and come back.
yes, taste you.
If you have a taser and you're willing to meet me off campus, unofficially, not on recording, we could talk. All right, let's keep cooking. All right, so any question? You missed the My Dumb class? You left and missed that? That's My Dumb class. It was our proof that we're calling our Singleton from a whole different quarter of our program. All right, so something as simple as this has now given us a variable that's accessible literally everywhere in our program. With this guy right here, if you say core.age anywhere in our entire program, it will be in scope. That's dangerous because that's super convenient, right? But only use it when it's the right tool for the job, when you really need something to be available to your entire application. Maybe the logged in username. You log into an application, your username is Mike. Rather than pass around the username through the entire program as you're navigating between pages, just put it in a Singleton and say, whenever you need the username, just ask. It's there. Make sense? That seems to be a better tool for the job than passing a username around 30 times. Go ahead.
So have like object format, I guess, if we're trying to do stuff.
I would say really the purpose of My Dumb class is to confuse folks like you. Yeah, so notice here, forget about the name of the class. Right here, we have two separate classes. We have a class called Driver, and we have a class called My Dumb class. You can call this class A, class B. Doesn't matter. The point is here, we've also now created this class called Core that has a static variable in it. And the goal here is that both of these classes, A and B, can access that single value in both of their classes without passing things back and forth. It's super convenient to get that value in both of these classes without any sort of gymnastics. That makes sense?
Yes.
So I just named it My Dumb class because we're going to be throwing this guy out. He's not going to be part of our program. Yeah, and if we can create 20 other classes and they all still have access to that guy. So it's just a super convenient way of getting data, getting values. It could be a function. We're going to write a function here in a second called like, get Pokemon by name. And it's going to go and get it for us and hand us it. We don't care how it did it. We're going to put our parsing stuff up inside this guy, get it out of driver. So it's up in from our perspective, the cloud, our little local cloud. And he'll do all the work and we'll just ask him for favors. As we need throughout our application, presumably we need the information about Pokemon, something like that.
Okay.
Go ahead.
If you were planned on never like repeating class names, what's the potential danger of having something be publicly accessible to the whole program? Does that make sense?
Well, okay. So when we say whole program, are you saying
In the
like
same way that we have core by dumb class, like
all the things that make up this single application, things that live inside of this folder? Okay, so what's the question?
Well, my understanding was, maybe my understanding from what it sounded like what you were saying is that early programmers will make the mistake of doing, there's this axiom of not having these globally accessible programs. Why? If we're not going to name a class twice on accident or something, if we're disciplined on our names, then what's the big problem with having something be globally available versus?
Yeah, so let me show you an example. So let's assume that in here, I want to create a variable int, oh, I don't want to put my weight. I might have to move to a long then. So we'll say int weight. How much would you guess I weigh?
I think you said
Hold on.
Maybe about 700.
All right, so I'm about 350 now. I used to be about 420. No, I never hit that. All right. So here's an example. So we'll put, so we have my behavioral age at 5 and my weight at 350. Can you imagine a 350-pound 5-year-old? Is it in a movie or something, or is this real life? Oh, I know the movie. Like it's a kind of a cartoony type thing.
Yeah,
I don't know if I've seen there was a sequel, I think.
maybe like Jumbo.
So, yeah, I mean, this is actually a true story. I mean, this is why, I think I probably mentioned it before. So my wife has stage 4 bladder cancer and she was supposed to be dead a year and a half ago. They gave her 2 years to live 3.5 years ago. And I'm a strong believer that God's keeping her around because I need adult supervision. Well, and I think there's some truth to it because so I have Asperger's, so it's a form of autism, and you usually are trading something. So I got a lot of intelligence, but something had to drop, and it was behavioral. So I require adult supervision, and we'll just all accept that. All right, so to answer his question, let's look at the alternative. Let's say, hey, I have a variable here, weight, and I want to share this throughout my application. All right. Now, I obviously have access to it here locally. I can say system.out.println weight, no problem. It'll print out, we got it. It's right there, it's local. But if I want one way or another, if I want my dumb class to get this value, I have to get creative, right? I can have that guy have like a setter to set that value in there, or maybe I pass it as part of the constructor. So I'll update my dumb class, and now he's going to, up here, he's going to, ooh, hello, just happened there. So up here, we might have a private, killing me. We might have a private int weight, and then this guy takes in an int weight, and then inside here, we say this dot weight is equal to weight, and then we can print out system dot out dot println weight. Now we have access to it. So then in here, where we call driver, when we create our dumb class, we have to pass it weight. Now he'll have access to the weight and can print it out. So there is the alternative of if I didn't want to use a singleton, in this case, I could have still gotten that value over to that other object. I just had to pass it to it one way or another. I could have, in this case, I'm passing it to it during its creation. I could have certainly created it first and then made a function to set that value. So for example, if I also want to have a int height, I'm like 6'3" or 4" now.
Like 5'2".
5'2", I says soon.
He's 5'2".
How many inches is how many inch? So 12 times 67, 72 inches. How tall am I?
Like foot.
Yeah, I'm 6'3" or 4". Let's say 6'3". 75. All right, 75 inches. Okay, so I can have my height, for example, and let's say I want my dumb class, obviously I can print out height here, right? So we'll now print out height in here. All right, so we'll print out height in here. It's local, no problem. Now, I can say my dumb class, he doesn't get height during creation, but maybe inside of my dumb class, we decide, okay, I'm going to have a private variable in here. I'm not going to set it in the constructor, but I'll have a void set height. This guy will take in an int height. He'll go ahead and print it out, system dot out. Well, here, we'll set the height. Let's just do it this way. So we'll say this dot height is equal to height, and then we'll have another function here, void display height. System dot out dot println this dot height. All right, so we'll call this set height method. So out here in driver, after I create my dumb class, my instance of it, I'll say mdc dot set height to this local variable height. Then we'll say mdc dot display height. And we'll get the height printed out there. So now I'll get height, weight, and age printed out here. Then I'll get, are we printing out, inside the constructor, we're going to print out weight first, I think. Then we're printing out age. Then we're setting the height. Then we're printing out the height. All right. So here was an example where we passed a piece of information in through the constructor. Here was an example where we passed a piece of information into another instance method of an instance of that class. And then we're calling another instance method to show that we can display that stuff. At the very least, what we've seen here is we have to take at least 2 or 3 steps per class, let's say, when we want to get a piece of information over to that class. Right? And let's say that you've been working on your program for a while and you're down at a place and you're like, oh, I just need this one value over there. And you might say, okay, well, look, is this a deal breaker situation? Is this worth backing up 30 minutes, going and putting it back in where it was, making sure I didn't break anything else that I've done in the middle, only to have that value? Or do I just throw it in my singleton, use it, move on with life? Depends. You have to use the right tool for the job, and sometimes the right tool for the job is I'm done coding for the day. And I'm not losing a half hour over a height variable. These are tools for us, so we pick the right tool out of the toolbox. So I think the whole point that we're looking at here is that singletons are super easy. They are so convenient to use, especially when you do it this way. If you use the built-in one, then you'd have to say core.get instance, and then you use that instance to call things from within it. Just seems stupid for me. I mean, you're not any performance you're gaining. If anybody wants to look into it and make an argument why this is a worse way, I'm certainly interested, but It just can't be more, any performance benefit you get can't be worth the convenience difference. So this is how I write my singletons. It gives you super trivial access to stuff across your program. Don't abuse it because it's easy to abuse, right? I mean, I have some old programs where, I was like, yeah, I'm the only one who's using it. I'm doing all sorts of stuff. And I'm like, okay, I need to get all this piece of information over. This was back in with Android coding. Because Android used to have a mechanism. Well, actually, Android and iOS have this, but Android's a good example for this since we're dealing with Java. Android would have this mechanism for getting information from the current page you're on to the next page you're about to launch. So when you click a button on Android, for example, another page swipes in. So it's actually built as a stack. So your application's in Android, it presents the first page of the program, and then when you log in, what it's doing is it's presenting another page on top of that. Then it's presenting another page on top of that. When you hit the back button, it takes this page off and shows you what you used to be looking at. It makes them, so that's a stack it's working with. Well, Android had built into it a mechanism for getting information from one page to the next page. And the way you launched a page in Android is through something called an intent. You would say, okay, you've pressed the login button. I've checked your credentials. Now you're good. So I now have the intent to launch the page one. Okay, but before I launch it, I now have an opportunity to pack some stuff in my bags. So it had something called put extras. So inside of this instance of this object called intent, it had effectively a dictionary called extras that you can just put name value pairs into left and right. Then when you got to the next page, you can say this, which was an instance of an activity. So every page in an Android application is something called an activity. In iOS, it's something called a view controller. And there's different kinds of view controllers. There's different kinds of activities, but you would have this activity, and then you could say this dot get extras, or this dot get extra, username, and it would give you the value. So it gave you this mechanism to pass your stuff along as you were launching new pages, which was almost like creating an instance. And it was inconvenient at best. When you think about the number of screens that you launch inside of an Android application or something like that. So I had singletons that just had everything under the sun in these things because I needed to have access to them in at least 2 different screens in my app. So I'm not going to spend time just packing my bags when I'm just taking a little trip down the street. You don't pack a suitcase to go to the grocery store, right? You just have all your stuff with you. You have easy access to it. You got it on your dashboard. You got your soda holder, whatever. So these are our singletons. Very powerful, very convenient to use. So for your homework, I'm going to give you this as a starting point. You already have a working version of our MVC stuff for the Pokemon. If you think that is superior to what you've already written, use mine. If you like your implementation of interacting with the API, it's going to be similar at some level, but if you just already comfortable with yours, use yours. But take your API and put it up into a singleton so that you can then ask that singleton, give me ID given name. Give me name given ID. I'll put this in an assignment so you have an example of it. But it's effectively the last assignment done through a singleton. So if you had the last assignment working, this won't be a giant leap. It's just going to be you kind of reorganizing stuff and maybe adding a couple of methods like get ID given name, get name given ID, something like that, however you want to do it. Make some sense? All right, questions. Oh, you got a question. Go ahead real quick. Is it a class question or is it? Okay, so questions, comments, concerns, bribes. All right, first row of chapel, if you're interested. I'll put this assignment up in probably in a half hour or so. And I will see everybody on Tuesday. We have class Tuesday, right? Yeah. There's no reason we don't. Yeah, you have to tell me when we don't have class. I don't look. What's up?
You have a midterm?
Oh, Well, I'll post about this. The midterm, I'll tell you what you need. It's going to be the usual. I'll put it up probably on Monday. It'll be due by end of day Friday before spring break.
Is it online?
It'll be online. Yeah, everything will be online. I'll give you a little message about it.